The accompanying data and frequency distribution are 45 commute times to work in minutes for workers of age 16 or older in Chicago. We want to use the data and frequency distribution to construct a histogram. Does it appear to be the graph of data from a population with a normal distribution? So when we take a look at each one of these examples, you can see that it's starting at 0. Okay? And so for A, B, and C, we can see that the class width goes from 0 to 15. 15 minus 0 is 15. If you look at D, we go from 0 to 10, and the class width is 10. Okay, so it looks like our class width is going to be 15, since there's 3 choices. Maybe it could be 10. Okay, and the starting point is at 0. So let's take a look at our data here. So here is our data. Okay, so here's our data, and there is our frequency. So let's take a look at our data, and then we're going to open it up. Okay, now while that data is open up, we're going to take a look at that. Okay, so here is our information, right? So we want to title this exactly what it says, and it says commute times in minutes. So we're going to write commute times, and then in parentheses, minutes. And again, you want to get in the habit of being able to write the title of the column so that when you do your project, you already know how to do that. Now we want to go over to graph and then select histogram. So when you select histogram, you're going to select commute times. Okay, and then the next thing we want to do is, we don't need to worry about where and group by, but we do need to make sure the type is frequency, since we're looking for the frequency histogram. Now, where is it going to start, meaning the bins? Well, we're going to start at 0. Okay, and then we're going to put in a width of 15, since 3 of our choices have a width of 15. And then we're going to put a value above the bar. We want to select that. Okay, and then we want to scroll all the way down. Now, on the x-axis, we want to write commute times, or commute time in minutes. Okay, the y-axis label should be the frequency, since that's what it's asking. Okay, and so we don't necessarily have a title, but we can say, either commute times to work. Okay, and so now what we're going to do is we're going to go ahead and select compute. So now you can see here is our histogram. Okay, so far we can see that we have an option here. So if we look at C, right, and A goes all the way up to 5 for 0 to 15. And then from 15 to 30, you can see that it possibly gets close to 13. And then from 30 to 45, you can see it's just a little bit above at possibly 14. And then 45 to 60 is 7. 60 to 65's got 5. And 75 to 90 is 1. So it looks like A could be our answer, but let's rule the other ones out. Well, if we look at C, it doesn't match at all. Okay. Now, if we look at B, you can see that the first 2 classes are the same height, but that's not what we get over here. Now, if we look at D looks like it goes to 5, it goes to 13, it goes to 14, it goes to 7, it goes to 5, and it goes to 1. Now, it looks like it could possibly be the same. Now, how do we decide whether or not it's either A or D? Well, let's take a look at our data, right? If we look at our data, okay, it either ends in a 5 or a 0. So therefore, we can possibly say that the width is going to be 15. Now, let's take a look at that. We're going to select A, check our answer, and that is our result. Okay, now we want to look at our histogram and determine, does this look like a normal distribution? So it starts a little bit high, it gets higher, and then it gets lower and lower and lower in the last 3. So what do we say about this? We can say that the histogram has a what? A longer right tail. So the distribution of the data is skewed to the right. And so the histogram does not appear to be the graph of data from a population with a normal distribution. And therefore that is our result.